जय श्री कृष्ण. Gate 1996. Question 2, 2.1. The ratio integration of x1 to x2 dx by y divided by x2 minus x1 by y at x equal to x2, x2 greater than x1 into 1 upon y is a monotonically increasing function of x. Is answer is A, that is less than unity. The ratio integration of x1 to x2 dx by y divided by x2 minus x1 divided by y at x is equal to x2 greater than x1 into 1 upon y is a monotonically increasing function of x is less than unity. 2.2. The reaction A plus B gives C has been conducted in a reactor x1. A gives x2 gives C A છે અંદર ને ફાઇનલ પ્રોડક્ટ A છે. જે A છે પ્રોડક્ટમાં A રિસાયકલ થાય છે. So the number of boundaries around which material balances can be written are 4. The number of boundaries around which material balances can be written are 4. Second, the number of independent balances that can be made around the reactor are 3. The number of independent balances that can be made around the reactor are 3. 2.3. For an isothermal variable volume batch reactor, the following relation is applicable for a first order irreversible reaction. Answer is B. CA0 divided by 1 plus epsilon y into xa into dxa by dt is equal to K. For an isothermal variable volume batch reactor, the following relation is applicable for a first order irreversible reaction. K is equal to CA0 divided by 1 plus epsilon a into xa into dxa by dt. 2.4. A rotameter through which air at room temperature and atmospheric pressure is flowing gives a certain reading for a flow rate of 100 cc per second. If helium molecular weight 4 is used and the rotameter shows the same reading, the flow rate is int Q2 by Q flow rate is 269 cc per second int Q2 by Q1 proportional to under root of FD2 by FD1 proportional to under root of rho1 by rho2. Now 2.6. The sphericity of a cylinder of 1 mm diameter and length 3 mm is. Answer is A, 0.9. Explanation: phi s is equal to 6 pp by sp into dp. Area sp is equal to pi dl. dp is equal to diameter of sphere of equal volume. Volume dp is equal to pi by 4 d square into l. 2.7. The hydrodynamic and thermal boundary layers will merge when Prandtl number is 1. The hydrodynamic and thermal boundary layers will merge when Prandtl number is 1. 2.8. When the ratio of the Grashof number to the square of the Reynolds number is 1, the dominant mechanism of heat transfer is mixed convection, both pre and post. Explanation: Grashof number is equal to inertia force into buoyancy force divided by viscous force square. Reynolds number is equal to inertia force upon viscous force. Therefore, Gr by Nre square is equal to buoyancy force upon inertia force is equal to 1. 2.9. The theoretical minimum work required to separate 1 mole of a liquid mixture at 1 atmosphere containing 50 mole percentage each of normal heptane and normal octane into pure compounds each at 1 atmosphere is. Answer is B, that is minus RT ln 0.5. Explanation: minimum work required for separation is equal to minus LG mixing is equal to minus RT summation of xi into ln xi is equal to minus RT into 0.5 ln 0.5 plus 0.5 into ln 0.5 is equal to minus RT ln 0.5. 2.10. Given 3H2 plus CO gives CH4 plus H2O. Kp is equal to 10 is to 1.84. And 4H2 plus CO2 gives CH4 plus twice H2O. Kp is equal to 10 is to 1.17. The Kp for the reaction CO plus H2O gives CO2 plus H2 is, answer is D, 10 is to 0.67. Explanation given. 3H2 plus CO gives CH4 plus H2O. Kp1 is 10 is to 1.154. And 4H2 plus CO2 gives CH4 plus twice H2O. Kp2 is 10 is to 1.17. For the reaction CO plus H2O gives CO2 plus H2. Now Kp3 into CO plus H2O is equal to CO2 plus H2 is equal to Kp1 into 3H2 plus CO is equal to CH4 plus H2O divided by Kp2 into 4H2 plus CO2 is equal to CH4 into plus 2H2O is equal to 10 is to 1.184 divided by 10 is to 1.17 is equal to 10 is to 0.67. 2.11. The rate expression for the heterogeneous category reaction is given by minus Ra is equal to K into Ka into Pa divided by 1 plus Ka into Pa plus Kr into Pr, where K is the surface reaction rate constant and Ka and Kr are absorption equilibrium constants of A and R respectively. With Kr Pr very greater than 1 plus Ka into Pa, the apparent activation energy E is equal to, even E is the activation energy for the reaction and del Hr and del Ha are the activation energy of the absorption of R and A. Answer is C, that is E plus del Ha minus del Hr. Explanation: since Kr into Pr very greater than 1 plus Ka into Pa minus Ra is equal to K into Ka divided by Kr into Pa by Pr is equal to K0 into Ka0 divided by Kr0 into Pa by Pr into exponential of minus E plus del Ha minus del Hz by Rt is equal to K optimum into exponential of minus Ep by Rt into Pa by Pr. 2.12 T. For a heterogeneous catalytic reaction A plus B gives C with equimolar fluid of A and B, the initial rate minus Ra0 is invariant with total pressure. The rate controlling step is desorption of C. For a heterogeneous catalytic reaction A plus B gives C with equimolar fluid of A and B, the initial rate minus Ra0 is invariant with total pressure. The rate controlling step is desorption of C. 2.13. When an exothermic reversible reaction is conducted adiabatically, the rate of reaction passes through a maximum. Explanation: since it is an exothermic reaction and no heat is removed, the temperature will rise continuously, therefore rate constant will increase. But as react, the rate will start decreasing, thus going to maximum. 2.14. A typical example of an exothermic reversible reaction conducted at high pressure in industry is dehydration of ethanol. A typical example of an exothermic reversible reaction conducted at high pressure in industry is dehydration of ethanol. 2.15. The transfer function for an ideal proportional plus reset controller is Kc into 1 plus 1 by tau s. The transfer function for an ideal proportional plus reset controller is Kc into 1 plus 1 by tau s. 2.16. An example of autothermal reactor operation is ethylene oxidation. An example of autothermal reactor operation is ethylene oxidation. 2.17. In a mixture of benzene vapor and nitrogen gas at a total pressure of 900 mmHg, it is absolute humidity. If the absolute humidity of benzene is 0.2 kg benzene per kg nitrogen, the partial pressure of benzene in mmHg is B, 60.3. Explanation. 0.2 kg benzene per kg nitrogen is equal to 0.2 by 78 kg of kilomole of citric acid divided by 1 by 28 kilomole of N2 is equal to 0.0718 by 1 kilomole C6H6 by kg mole N2. Therefore, PC6H6 is equal to 900 into 0.0718 divided by 1.0718 is equal to 60.3 mmSg. 3. Guess the following. 3.1 gear pump for viscous oil, gear pump for viscous oil, air lift pump for suspension, air lift pump for suspension. 3.2 jacket side and vessel. સ્ટીમ ને વેસલમાં વોટર છે. આન્સર ઇઝ સી 285 and 800. Overall heat transfer coefficient watt per meter square degree centigrade. Jacket side steam overall heat transfer coefficient 285 and for vessel water 800 watt per meter square degree centigrade. Second water jacket side છે તો overall heat transfer coefficient 850 watt per meter square degree centigrade and polymer monomer mixer છે તો 1700 watt per meter square degree centigrade overall heat transfer coefficient polymer monomer mixture માટે. 3.3 1/7th power law is irrotational flow. 1/7th power law irrotational flow માટે Hazen-Poiseuille equation laminar flowing pipes. Hazen-Poiseuille equation laminar flowing pipes. 3.4 grades number thermal developing flow. Grades number thermally developing flow and Rayleigh's number heat transfer in creeping flow. Heat transfer Rayleigh's number heat transfer in creeping flow. 3.5 first RTD for laminar flow del into T minus tau. RTD for laminar flow del into T minus tau and RTD for CHTR exponential of minus 1 by tau. RTD for CHTR exponential of minus 1 by tau. 3.6 trickle bed reactors dehydrogenation of butanol. Trickle bed reactors dehydrogenation of butanol and batch reactors hydrodesulfurization of petroleum fractions. Batch reactors hydrodesulfurization of petroleum fractions. 3.7 flow factor hydrocyclone. Flow factor hydrocyclone and grade efficiency mixing. Grade efficiency mixing. 3.8 saltation velocity pneumatic conveying. Saltation velocity pneumatic conveying and compressible cake that is filtration. Compressible cake for filtration. Saltation velocity pneumatic conveying and compressible cake for filtration. And Jai Shri Krishna.